Good morning. Welcome to the last class session of the semester. It's been a long journey. Before we start, I would like to remind you all the teaching evaluations. You're highly encouraged to fill out teaching evaluations, share your experience with the class. If your overall learning, if it was a good experience or bad experience, either way, I think you should share what you think about this class and how the class can be improved. Obviously, it was very different than normal under these circumstances. So yeah. I'm assuming everybody received my message yesterday, the announcement I made about the final exam and the grading policy. Any questions on that? So today I'm gonna go over test 3. So I want everybody to go to WebAssign and open the test 3. And you should be able to see how much partial credit you got from each problem, and also the solutions and answers. It should be among your past assignments. It's called test 3 Proctor U. Did everybody pull up the test 3 and WebAssign? And can you guys see the grades you got for each problem? I'm assuming everybody pulled up test 3, so I'll go over test 3 problems today, and you'll be able to see your mistakes. The first problem, I think it's a geometric series problem. You're given 5 to the power of n plus 1, 6 to the power of negative n. By the way, let me briefly mention about the grading criteria. If you got the correct answer on WebAssign, but if your work is wrong or if you didn't submit any work, you get the 80% of the credit. In other words, 20% of the credit is taken off. For the problems 3, 4, 5, even if your work is wrong or even if you don't submit work, if your answer is correct, you get full credit on 3, 4, 5. And in other problems, we used the partial credit criteria. So for example, in this problem, number 1, if you got the common ratio correct, you get 1 point, and if you get the sum correct, you get 1 more point. So how would you determine if this series is convergent or not. First of all, you should see that most of you did. This is a geometric series and can be written as 5 to the power of n times 5 over 6 to the power of n. And this means 5 over 6 to the power of n times 5, and it's a geometric series. And r is 5 over 6, so it's less than 1, it will be convergent. So once you figure that, you need to find the sum, and the sum is going to be the first term over 1 minus r. The first term, if you plug 1 for n, I think you will get 5 over 6 times 5 over 1 minus 5 over 6. And if you do that, I think you will have 25 over 6 over 1 over 6, which is 25. Any questions on the first problem? The second problem, most of you got the, well, I think everybody got the correct answer, but only a few of you got the correct answer using the correct way. So this is a typical test for divergence problem, because if you look at the series, you can see that as n goes to infinity, this limit is not 0. So 1 over 9 plus e to the power of negative n. What is e to the power of negative n as n goes to infinity? It's 0, right? So we'll have 1 over 9, which is different than 0. Then by test for divergence, the series is divergent. Again, I think pretty much everybody got the correct answer because there were only 2 choices. But if you use another method which doesn't make sense, 0.8 point is taken off. Any questions so far? The third problem, we got to do integral test. It's given. Those of you who joined late, please open the test tree and web assign. It should be among your past assignments. And I also want you to check the partial credit you got from each problem, because I might have made a mistake. I try to be very careful, but still, you might want to double check. And if I made a mistake on the partial credit, let me know. I can fix it. As I said, in the problems 3, 4, 5, if your answer is correct, then you get full credit regardless, even if you don't submit work, even if you didn't submit work, or even if your work is incorrect. And the other problems, if your answer is correct, but if your work is incorrect, if you use another method than I used, which doesn't make sense, then you should get the 80% of the credit. That was the case for most of you in the second problem. That's why most of you got 3.2 out of 4. I took off 0.8 point. So we're given that we got to use the integral test. Most of you got the integral is finite and the series is convergent. So you should get 2 points for that. And if you write the improper integral this way, you're getting 1 more point. So that's why most of you got 3 out of 4 in this problem. And if you get the result of the integral is correct, which is the first box, then you're getting 1 more point, which adds up to 4. So how can we integrate this integral? X times e to the power of negative 9x. It will have to be integration by parts. So x is polynomial, e to the power of negative 9x is exponential. So I think we will have to call x u and e to the power of negative 9x dx dv. By the way, this is t. So dx is du, and e to the power of negative 9x over negative 9 is v. Then we'll have this limit t goes to infinity, x times e to the power of negative 9x over 9 minus v du e to the power of negative 9x over negative 9 dx. Right? X is polynomial, e to the power of negative 9x is exponential, so it will be e to the power of negative 9x over negative 9. So let's try to integrate the e to the power of negative 9x. And before we do that, let's try to simplify this expression a little. So this is going to be 1 over 9, the integral of e to the power of 9x, which is going to be this. Any questions so far? So if you plug t, what happens? I think you will need to do L'Hopital for the first part. Times t over e to the power of 9t minus 1 over e to the power of 9 plus, maybe we should say minus 1 over 81 times e to the power of 9t minus e to the power of negative 9. Now, here, the term that will give us trouble is this guy, because it's infinity over infinity. And to take care of that, you will need to use L'Hopital. and I think eventually it will be 0. Let's see. It will be 1 over 9 times e to the power of 90, and yeah, this will be 1 over infinity, which is 0. So this is 0. We don't need to worry about that. What about e to the power of negative 90 as t goes to infinity? I think it will be 1 over infinity as well. So this is also 0. So what you have is 1 over negative 1 over 9 times e to the power of 9 plus 1 over 81 times e to the power of negative 9. And this was a fine answer, but if you simplify that using the same denominator, which you didn't have to, I think you would get 8 over 81 e to the power of 9. But yeah, this is fine. So it's convergent. This is finite, and the integral convergent. Any questions on this problem? I think this was supposed to minus, which is a very small change. So this is going to be plus. Yeah. And I didn't really take up points for this kind of small mistakes in this exam. So it wasn't a big deal. Now the fourth problem, as the question says, we need to use limit comparison test. And most of you got this right. Let's quickly go over 9 over n squared plus 5 in my version. So an is 9 over root n squared plus 5. Then bn is going to be, if you go by the highest order terms, this is LCT. The question is already telling us that it will be 9 over root n squared or 1 over root n squared, either works. And this is 9 over n. It's divergent by p series because p is 1. And then if you calculate the limit an over bn, the 9s are gone. And if you flip n, I think the limit is going to be 1, which verifies that we can use limit comparison test. Then we can say the series diverges by limit comparison test, because each term is greater than that of the limit of the ratio of its terms, and the harmonic series, which is 9 over n, is greater than 0. Any questions on 4? And 5? Pretty much everybody got this one right as well, so I'll quickly go over. The question is already telling that we need to use the root test. So AN is the original series. First, you need to identify AN. Then the limit as n goes to infinity. In the absolute value, of course. So you will have the n's canceled out. So it will be n squared plus 1 over 7 n squared plus 6. And if you go by the highest order terms, I think it will be 1/7. So the first box should be AN, the original series, and then the second one is the limit 1/7. Since it is less than 1, it's going to be absolutely convergent or just convergent by a root test. I think pretty much everybody got this one right. Number 6, the radius of convergence and interval of convergence. So the partial credit criteria in this problem was, if you use ratio test and everything else you did was wrong, you get 1 point. If you get the absolute value of x minus 4 less than 1, which gives you radius of convergence, you get 3 points. And then checking each endpoint is 1.5 point. So let me give more details in this problem, because this problem is a problem pretty much everybody attempted and most of you got partial credit. So we -1 to the power of n plus 1, x minus 4 to the power of n plus 1 over 2 times n plus 1 plus 1. And if you flip that to n plus 1 over -1 to the n times x minus 4 to the power of n. Now here you'll have -1, which will go away because it's an absolute value. X minus 4 to the power of n plus 1, x minus 4, you will have 1 x minus 4 on the top, and 2n plus 1 over 2n plus 2 plus 1. As n goes to infinity, this will be 1. So what you have is just x minus 4. And it will be less than 1. Any questions so far? And this gives you r as 1. So if you started with ratio test, you get 1 point, as I said. If you got this x minus 4, you get 2 more points. And if you get the radius of convergence right, you get 1 more point. And then checking the endpoints, x minus 4 is less than 1 and greater than -1. So x is less than 5 and greater than 3. So you got to check x equals 3 and x equals 5. When x is 3, I think this series becomes -1 to the n times 3 minus 4, which is also -1 to the n, 2n plus 1. So -1 times -1 is going to give you 1. You will pretty much have 1 over 2n plus 1. And this is going to be alternating, not alternating because it's 1. This is going to be limits comparison test. Choose the Bn as 1 over n, which is divergent. And you can verify that 1 over 2n plus 1 over 1 over n will give you a positive finite number, which is 1/2. So then by limit comparison test, the series doesn't converge when x is 0, when x is 3. And then this whole part was 1.15 point. So is the second endpoint x equals 5. If you plug 5 for x, I think you will have -1 to the n times 5 minus 4 to the power of n. So it will be -1 to the nth over 2n plus 1. It's going to be AST, and Bn is 1 over 2n plus 1. It satisfies all conditions. Its limit is 0. So the series converges when x is 5. Then I is going to be parentheses for 3. Don't include 3 and include 5. And 1 point for this last answer, which add up to 8 points. Any questions on 6? Number 7 was one of the hardest problems in the test. So this is power series problem. First, you need to find the power series of 1 minus 2x. First of all, let's separate this fraction as x squared over 1 over 1 minus 2x squared. Okay. The key point is finding this guy. What is the power series representation of that? Once we find that, we'll just multiply it by x squared and then we'll get the right answer. So 1 minus 2x squared, what do we know about that? What do we know about the power series? Only thing we know is 1 over 1 minus function is always gonna be f of x to the power of n. Okay, so how can we manipulate 1 over 1 minus 2x squared to the regular power series form? I think the only thing we can do is finding a relationship between 1 over 1 minus 2x and 1 over 1 minus 2x squared. So 1 over 1 minus 2x, let's talk about its derivative. You can use quotient rule or you can use the chain rule. If you do the chain rule, 1 minus 2x to the power of negative 2 times negative, I think it will give you 2 over 1 minus 2x squared. Okay, so the derivative of 1 over 1 minus 2x, which is pretty much 2x to the power of n, its derivative is 2 over 1 minus 2x squared. And how can we calculate the derivative of this guy? It will be 2 to the power of n times x to the power of n, and if you differentiate that, 2 to the n times x to the power of n minus 1. And this is 2 over 1 minus 2x squared. Remember, we're after 1 over 1 minus 2x squared. If you divide both sides by 2, I think it will give you 2 to the power of n minus 1 times n x to the power of n minus 1 as 1 over 1 minus 2x squared. And the last step is multiplying this by x squared. I think this should be the right answer. And as far as the partial credit, this problem is worth 6 points. If you got the R correct, you get 2 points. And if you get the if you think of the derivative, the taken derivative of 1 over 1 minus 2x, you get 2 points. And then if you manipulate it to x squared over 1 minus 2x squared, you get 2 more points. Maybe I should say this is 2 points, and then this is also 2 points. And R, let's talk about R. I think you got to do the ratio test. So 2n to the power of n minus 1 and x to the power of n plus 1. Then a n plus 1 will be 2 to the power of n times n times x to the power of n plus 2. So this is going to give us 2. This is going to be, the ends will be gone, and then x to the power of n plus 2, x to the power of n plus 1 will give us x. So we'll have 2x less than 1. We're trying to find r, so I think r is going to be 1/2. And this is worth 2 points as well. Any questions on number 7? Number 8 was the other hard problem in the test. You need to approximate this integral correct to 6 decimal places. So the error is going to be less than 5/10 to the 7th. So I think you should start with arctangent. What is the power series representation of arctangent? And then arctangent of 3x. Well, actually, we can directly find the power series of arctangent of 3x. Let's start with that. Arctangent of 3x, its derivative is 3/1 plus 3x squared. In other words, 3/1 plus 9x squared. So arctangent of 3x is actually 3 times 1 minus negative 9x squared so it will be negative 9x squared, which is, if we keep going, we'll have an alternating series, negative 1 to the power of n, 9 to the power of n times x to the power of 2n. And this can be rewritten as negative 1 to the n times 9 to the power of n is 3 to the power of 2n. If you multiply it by 3, you'll have 3 to the power of 2n plus 1 times x to the power of 2n. So this is, again, the derivative of arctangent. Okay, but we need the arctangent of 3x itself. So you gotta take the integral of both sides. If you do that, the arctangent of 3x will turn out to be 3 to the power of 2n plus 1 times x to the power of 2n plus 1 over 2n plus 1 plus c. And if you plug 0 for x, you'll see the left-hand side is going to be 0 and the right-hand side is going to be c. So c turns out to be 0. So this is arctangent of 3x. And then we need to find x times arctangent of 3x. If you multiply it by x, I think what will happen is So this is x times arctangent of 3x, I believe. Any questions so far? And then if you integrate that from 0 to 0.1, the only change is going to be the power of x, which is going to be x to the power of 2n plus 3 over 2n plus 3. And then if you plug 0.1, and this is the series we would have. And then if you plug, if you write out some terms of this series, I think you will have, when n is 0, when n is 0, you would have 3 times 0.1 to the power of 3 over 1 times 3. When n is 1, I think it will be 3 cubed times 0.1 to the 5th over, when n is 1, it will be 3 times 5. Can you see the pattern? The powers of 3 increase by 2, so is the powers of 0.1, and the numbers in the denominator, they're increasing by 2 as well. So the next one is going to be 3 to the 5th, 0.1 to the 7th over 5 times 7. So we got to keep going until when? The alternating series estimation theorem state that the error is always less than or equal to be n plus 1. So, and we want it to be less than 5 over 10 to the 7. So you got to keep going until you find a term that is less than 5 over 10 to the 7. And if you check that, I think you'll see that term is the 5th term. I think it will be 3 to the power of 9, 0.1 to the 11 over 9 times 11. That's less than 5 over 10 to the 7. So it turns out n plus 1 is 5. You need the first 4 terms. And then if you add up the first 4 terms, I think it's going to give you, in my case, 0.000983. And the partial criteria in this problem was, if you get arctangent of 3x right, you get 2 points. If you multiply it by x correct, you get 1 more point. And then if you integrate it and plug in the boundaries, you get 2 more points, and 1 point if you write out the terms, and 2 points if you do the approximation right. Any question on number 8? Okay, let's quickly solve 9 and 10. They're not that long. So Taylor series of f of x 3x e to the power of x at a equals 0. You got to do a chart for this problem. And it says first 4 non-zero terms. So maybe we won't need the last one. Let's see if the first term is non-zero, then we won't need the term when n is 4. So 3x to the power of e to the x. If you plug 0, I think it will be 0. So it means we will need when we will need the term when n is 4. What is the derivative of 3x times e to the power of x? Some of you messed up with the derivative. You gotta do a product rule. So if you do a product rule, the derivative of 3x times e to the power of x is gonna be 3e to the x plus 3x e to the x. The derivative of 3x times e to the x plus 3x times the derivative of e to the x, which is going to be 3e to the x plus 3x e to the x. And then similarly, the derivative of 3e to the x is going to be the same, and the derivative of 3x e to the x is going to be exactly the same as the previous box. I'm assuming everybody sees the pattern here. So when you plug 0 for x, this is going to be 3, this is going to be 6, this is going to be 9, and the other one is going to be 12. Now we can write out this Taylor series real quick. It will be 0, we don't need to worry about that. And then 3 times x over 1 factorial, 6x squared over 2 factorial, 9x cubed over 3 factorial, and 12x to the 4th over 4 factorial. And this was an acceptable answer. In the partial credit criteria, if you got the derivatives right, it's 2 points. If you plug the numbers correct, you got 1 more point, and the last step is also 1 more point. Any questions on 9? Okay, let me do 10. It will take me less than a minute. One over n plus 4 to the n if you compare this to 1/4 to the n, you see that it's always less because it has less denominator. 1/n+4 to the n has a larger denominator, and this is convergent by geometric because r is 1/4, right? And by comparison theorem, the series is convergent. And pretty much everybody got the right answer, but if you used another test that doesn't make sense, then 1 point must have been taken off. Any questions on the test 3? Right. I want to thank you all for being good students, for hard work. It was a pleasure to teach this class. I really enjoyed teaching, and I hope you do well in the final. You do your best in the final, and I'll do my best when I give your final grades. I'll try to be as lenient as possible, and let's see how it will go. So thank you, and have a good final exam week. Thank you. You're welcome. You're welcome.